गुड इवनिंग एवरीवन। नमस्कार सभी को, स्वागत है आपका हमारे इस प्लेटफॉर्म पर जिसका नाम है 1 मार्क सॉल्यूशन। जैसा कि आप सभी जानते हैं कि हमारे साथ लगातार डिफरेंट सब्जेक्ट्स के डिफरेंट एक्सपर्ट्स हमारे साथ जुड़ते आते हैं और जो कि आपकी 1 मार्क्स के जो क्वेश्चन होते हैं, जो बहुत ही सॉलिड मार्क्स रहते हैं 1 मार्क्स के, फिल इन द ब्लैंक्स, MCQ बेस्ड क्वेश्चंस जो रहते हैं, उनके जो एक्सप्लेनेशन होते हैं वो यहाँ पे एक्सपर्ट्स आके बहुत अच्छी तरीके से आपको क्लियर करते हैं जो उनके एक्सप्लेनेशंस होते हैं। और इसी श्रृंखला में आज हमारे साथ स्टूडियो में हैं, मैं मैम का स्वागत करना चाहती हूँ, नुपुर श्रीवास्तव मैम, जो कि पीजीटी केमिस्ट्री हैं IIM लखनऊ, KVIM लखनऊ में। और मैम आज एक्सप्लेन करने वाली हैं आपको चैप्टर 10, क्लास 10 के लिए चैप्टर 3 साइंस, मेटल एंड नॉन मेटल्स। मैम ने पहले भी यहाँ पे इस प्लेटफॉर्म पे प्रेजेंटेशन दिए हुए हैं, तो आप लोग को पता होगा, मैम को एक्सपीरियंस है। मैम बहुत अच्छी तरीके से प्रेजेंटेशन के थ्रू आपको एक्सप्लेन करेंगी जो आपके 1 मार्क्स के क्वेश्चन रहते हैं। तो मैं बहुत ज़्यादा टाइम नहीं लेते हुए मैम को हैंड ओवर करती हूँ। मैम प्लीज़ शेयर योर स्क्रीन PPT।
Thank you, Priyanka. Is it okay, the screen?
Yes, ma'am. Yes, ma'am. Yes, ma'am. It's okay. Yes, ma'am. You can start. और जो भी हमारे व्यूअर्स हैं उनको मैं बताना चाहती हूँ कि प्रेजेंटेशन के बाद मैं एक कमेंट बॉक्स में एक फीडबैक फॉर्म डालूँगी, इसलिए आपको लास्ट तक देखना है ये वीडियो और फॉलो करना है उसको। प्रेजेंटेशन के बाद एक कमेंट में एक फीडबैक फॉर्म आएगा जिसमें कुछ क्वेश्चंस रहेंगे। 40% अगर आप उसको क्वालिफाई कर लेते हैं तो आपके ईमेल आईडी पे एक सर्टिफिकेट आपको मिल जाएगा। तो आप इसको वॉच करिए और फीडबैक फॉर्म ज़रूर भरिए। तो लास्ट तक इस वीडियो को देखिए। थैंक यू। Yes, ma'am. Yes, ma'am.
Okay. Good evening, students. Those who have joined this session, I would like to say that we have already dealt with the part 1, which was general metals and non-metals. Today, we are starting with part 2, which deals with the metallurgy. Now, metallurgy, children, is a very important topic, and lots of 1 mark questions and assertion and reasoning questions are framed from this part. So we have to start being very careful about those small little things that are in this metallurgy chapter. So going ahead, let us start with just a general view. In this, the questions that are asked are from the ore. Then the next one is from the various steps involved in converting this ore into pure metal. So basically our questions, the 1 mark questions, can come from any of the steps that are involved in metallurgy. And so the slides tells you which part to concentrate on, because from every part 1 mark questions can be framed, and we shall be seeing the various questions that are from the board exams. So the first thing was about ore. So this question is, hematite is an ore of. The options given to you here are iron, aluminium, copper, tin. Of course, options may vary, but then the The answer over here is iron. So, hematite is an ore of iron. Here another question comes up, that what exactly is a mineral, and the questions can be that whether this is an ore or a mineral. So any compound of iron will be called mineral, or for that matter any metal. But ores will be only those minerals from which we can extract a large amount of that metal. And the process involved in extracting all of these is called metallurgy. Let's go to another such type of question. So the question is, of course, cinnabar is an ore of, and we have the four options given to us. And cinnabar, because this is again very commonly asked, the ores which are not named as a chemical compound, but certain names are given, those will be very frequently asked. So we discussed once hematite, and now this is the next one, cinnabar. So cinnabar is the ore of mercury. So children, I hope you have understood that we have to be very careful with those ore which have got the typical name, a different name. The next question that is on your screen is, which of the following metals occur in pure state? So not all metal will occur as compounds. The choices given are copper, iron, zinc, and gold. So the answer over here is gold. Gold does not react with any of the non-metals, and therefore it generally exists in its native state. It can be just extracted by simple chemical means. We can separate all the other things that are present along with that pure gold dust or pure gold stones. Okay, so you know that Kolar has got the gold mines. The next question again which follows is of the same type. Which of the following metal exists in its native state, that is in its normal state? The options given to you are copper, gold, zinc, and silver. Now over here, you all know that gold exists, but the answer is your the answer over here. Actually, there is the same. Which of the following uh, exists in its native state? So we will find we can have zinc and your silver. They can, along with that gold, they can exist in their native state. The next one is, when we start with ore, we have to have the removal of impurities. Ore will generally be extracted from the underground, and so we have to remove certain impurities. And we want to know the name of this process. So the answer to this is concentration of ore. Concentration of ore means we increase the quantity of the mineral of the metal and remove all other minerals which are not of that metal. So that method is called concentration of ore. Moving on to the next question. Moving on to the next question. A fourth flotation method is used for the concentration of. Now the fourth is generally the bubbles, the, you can say, the foam type of thing that gets formed. And that method is used where? For the oxide ores, the sulphide ores, the sulphate ores, or the halide ores? Now, the answer over here is sulphide ore. All the sulphide ores are concentrated by froth flotation method. That means formation of lot of foam, and the foam contains all the sulphide ores. So zinc sulphide, copper sulphide, these are the examples for this. In froth flotation, we will take a crushed ore in a large tank, and it will contain some oil like pine oil, and lot of compressed air is passed. So the ore will get wetted by oil, and it is separated from the impurities in the form of froth. And this ore, which is lighter, and it comes to the surface, and the impurities are left behind. So this is the picture of the froth flotation method. Next, there is another method, and that is called magnetic separation method. Here, the crushed ore will be placed on a conveyor belt, and this belt will rotate around the two wheels, and one of the wheel is magnetic. So the magnetic particles will stick to the belt, and when the belt turns round, then the non-magnetic parts will fall off, and the magnetic parts will be left behind. Okay, now we are asked the next question. Hematite is an ore of iron. Can it be concentrated by magnetic separation? So, true or false, when you have to select, the answer over here is true. It is quite true, because iron, gets attracted by magnet. Now, the process in which a carbonate ore is heated strongly in the absence of air to convert it into a metal oxide. So, there is a process when we have some carbonate ore, and this carbonate ore, they are heated strongly in the absence of air, and then the carbonate breaks down into the oxide, and of course gives out carbon dioxide. So you are asked that which is the process that does it. So 4 are given: roasting, reduction, calcination, and smelting. The answer, which is on your screen now, it is calcination. Calcination will be when you heat a carbonate ore or any oxygen-rich ore in absence of air. Then it is called calcination. Going on, heating of concentrated ore in absence of air for conversion into an oxide ore. The answer, of course, is your calcination. We have repeated this question because this question can be asked in more than one ways, and sometimes they simply give you that we are heating a carbonate concentrated ore which is carbonate in nature, and it is heated in absence of air. Sometimes they don't give you the type of ore, the name of the ore is not given, and you are simply asked that we are heating it in absence of air. So we have framed the two questions in two ways. The highly reactive metals like sodium, potassium, and magnesium. Now there is a special method only which we can use for extracting them. So the options given are electrolysis of their molten chlorides, electrolysis of their oxides, reduction by aluminium, or reduction by carbon. So you have to be careful because out of A and B, you have to select one of them. Okay? And the answer is electrolysis of their molten chlorides. See, when the name is given, sodium, potassium, and magnesium, which are highly reactive, they are high in the reactivity series, which you have seen in part 1, then it will be their chlorides. Aluminium can be extracted by electrolysis of its molten oxide. So here, as I said, you have to be very careful on the type of language used in the question. Moving on to the next one. Which process is used for extraction for the concentration of bauxite ore? Now, the given choices are froth flotation, leaching, liquation, and magnetic separation. So, you can start eliminating. You know that since the formula does not show it is a sulphide ore, so it cannot be froth flotation. Since it is non-magnetic, so it cannot be magnetic separation. And now we are left with the two choices. Liquation will be used when the metal is actually very low melting point metal. Okay, so over here we know that aluminium does not have a low melting point. So that leaves us with a choice of leaching. And answer is also leaching. Here, children, remember that all the metallurgy questions are a little bit tricky. So we have to pay attention on the language of the question. And of course, we have to sometimes follow the process of elimination. We move on to the next one. But before we move on, let us understand what exactly is leaching. Now, leaching, we will use a solvent over here, NaOH, in which only the ore will dissolve, but not its impurity. And when it dissolves, it forms a very nice solution, but impurities remain insoluble. And then from this dissolved state, it can be precipitated out. In this case, by passing lots of carbon dioxide, bubbling carbon dioxide, where the bicarbonate gets separated out and aluminium hydroxide is separated as a solid. And once we heat it, we get what is called pure alumina, Al2O3. Now, the reaction given on the right hand side is also very important because you may be given a part of the reaction and you may be asked to identify the right hand side product that is getting formed. The right hand side product that gets formed over here. Okay. Now, bauxite, cryolite, alunite, and feldspar. These are names of ores only. And incidentally, the language of the question says the chief ore. And so the answer over here is bauxite. Though all of them contain aluminium, but we know that it is bauxite which is the main ore. As we have said, bauxite, hematite, cinnabar, zinc blende, These are the names that we will have to always remember because questions can be framed from those. Uh, the extraction of metals. Now, you can also get the small questions as uh, fill in the blanks. So, the extraction of metals from the ores and then refining them for use is known as, that we have seen, it is called metallurgy. The whole process is called metallurgy. Going on to the next one. In thermite welding, a mixture of dash and dash is ignited with burning magnesium ribbon, which produces molten iron metal as large amount of heat. Now, this particular question, dear children, is very, very common. Hardly a year goes by when you are not asked this question in some form of the other. Some form or the other, you will be finding this. So here they have already given you the name, thermite process, thermite welding process. And here you have to identify what are the two things that are taken in this thermite reaction. Now you have been given a lot of choice, 4 choices. Is it iron 3 oxide and aluminium powder, iron 2 oxide and aluminium powder, iron 3 chloride and aluminium powder, or iron sulfate and aluminium powder? In this thermite process, which also is called aluminothermic process, we know that aluminium powder will be present because its name itself is aluminothermite process. And since we have to do produce molten iron, so definitely there will be a compound of iron. Now, out of the 4 compounds of iron, we have to select the correct compound. We know that thermite process, which produces molten iron, should contain aluminium and should contain one compound of iron. Which it is, we will know. And it is Fe2O3, iron 3 oxide, and aluminium powder. So, this is a very important question, and this is also the reaction that occurs. You will get Al2O3, you will get molten iron, and lots of heat is produced. That is why it is called thermite process. And so, another style of the question is write down the reactions involved in thermite process. So, this slide covers all 2 types of questions at least that will come. Aluminothermite reaction is also known as Goldsmith's reaction, and it's highly exothermic. Exothermic means gives out heat, and generally iron or chromium oxides are heated to high temperature with aluminium, and we will get the metal in molten state. So, this is the explanation for this. Which of the given metals cannot be extracted using smelting? Which of the given metals cannot be extracted using smelting? Now, choices are iron, aluminium, zinc, and lead. So, let us see the answer and then we shall go for the explanation. So, answer is B, smelting. What exactly the meaning of smelting? Smelting has got that word melting also. So when we heat something to a very high temperature and then use carbon or coke to remove the oxygen, Remove the oxygen. See, we can have an ore of iron, which is an oxide ore of aluminum, oxide ore of zinc, ZNO, oxide ore. Actually, we get that ZNO from zinc carbonate, converts into zinc oxide. And similarly, we have got PbO or Pb3O4. All of them exist as oxide ore. But smelting cannot be used with aluminium. All the other three have to be heated with carbon or coke and at very high temperature, and then they get reduced. So here, separating the metal from excess and unwanted materials by using high temperatures is called smelting. Okay. Now, we have talked about ores and we have talked about how the ores can be converted into oxide forms. And we have also talked about the methods of reducing the oxides. Now we come to some questions in which the refining of the metal will be taken up. And so here we have which metals are refined by using different method. That's a statement given to you. Now, which of the following metals are refined by electrolytic method? So a pair of metals are given: gold and copper, gold and sodium, copper and sodium and potassium. Fine. Let us see the answer. And you must have guessed that it has to be your gold and copper, which can be refined because the others are extracted. Sodium and potassium are extracted by electrolytic method. Okay, so we don't need to refine them. And here, gold and copper, we will be seeing some more methods how copper can be refined by this. Okay, so gold and copper. Now, extraction of copper, the flux used is sometimes the impurity that is present with the ore is also a compound. And to remove it, we have to add another compound. This compound will only and only act or react with the impurity. And therefore, that extra compound that we add with the ore to remove the impurity, to combine with the impurity and remove it, is called flux. And now, in the extraction of copper, which is that compound that is used as flux? The answer is SiO2, sand. Simple, common sand. SiO2, also called sand. And so, this is the answer to your flux used in extraction of copper. Now, we come to another very interesting question, and this is again a question which is very, very common. There is a reaction given to you. You can see copper sulphide is reacting with copper oxide, and you are getting copper and sulfur dioxide gas gets removed from it. Sulfur dioxide will be just rising up and moving out. Now, what is this process called? Whether it is auto reduction or a chemical reaction is occurring, so it is a chemical reduction, or is it electrolytic reduction, or none of these, right? So definitely there is no electrolysis involved, so it cannot be electrolytic reduction. But our point rests on whether it is A or B. So let us see. The answer is A, auto reduction. See, the sulphide and the oxide ore, the sulphide and the oxide ores, they are reacting with each other and they are reducing themselves to metallic copper. Okay, so that process is called auto reduction. Now we come to another part. Once you have extracted metals, you have to learn certain uses of these metals. And now, stainless steel is very useful material. We know we've got lots of things made up of. Apart from utensils, there are so many of our mechanical things, or let us say implements, that are made of stainless steel. So, which of these are mixed with iron? Nickel chromium, copper chromium, nickel copper, and copper and gold. So let us see. The answer is nickel chromium. The answer over here is nickel chromium. Okay? And whenever a metal gets mixed with some other metal, then that is called alloy. Okay? And alloys are homogeneous. When you look at stainless steel, you cannot make out where is the iron, where is the chromium, where is the nickel. Okay? And what does alloy do? It enhances the desirable properties of the metal. Like it makes it more hard, it increases its tensile strength, and it makes it resistant to corrosion. Resistant to corrosion. Okay? So, an alloy is. Now that you have learnt in the previous slide about alloy, is it an element? Is it a compound? Is it a homogeneous mixture or a heterogeneous mixture? So you will be ready with your answer, and that is, it is a homogeneous mixture. Okay. Now we have talked about alloys. They are a mixture of metal with another thing, some other thing. So we have also seen that they are homogeneous, right? And when we mix, it is not only that metal that can get mixed. We can also be mixing a non-metal. So, which among the given alloys contains a non-metal as one of its constituents? Brass, bronze, amalgam, or steel? See, some of the alloys are totally, completely made up of mixing of metals only. So let us see the answer. And it is steel, because a small amount of carbon will get incorporated when the alloy is getting made over here. Let's go on to the next one. And again, this particular question in various forms, whether it is fill in the blanks, whether it is as a reason why bauxite is mixed with cryolite, or it is as a multiple choice question. So, bauxite is mixed with cryolite, bauxite and ore of aluminium. And why is it mixed with cryolite? To reduce its melting point, increase its electrical conductivity, molten cryolite acts as a solvent, or it increases the melting point of bauxite. Okay, so let us see. This is a multiple choice question where more than one can be your right answer. So A says it is 1, 2, and 3. That means the melting point will be reduced, electrical conductivity will also increase, and the cryolite acts as a solvent. B says that it will be 2, 3, and 4. That means electrical conductivity is increased, it acts as a solvent, and melting point also gets increased. C says 3 and 4. Cryolite is acting as a solvent and it is increasing the melting point. And D says 1 and 2. That melting point is reduced and of course, the D is 1 and 1. That means that is the only choice, none other. So let us see what is the answer. And the answer is A. 1, 2, and 3. These are all the three reasons why bauxite is getting mixed with cryolite. We go to the next one. In the electrolytic refining of copper, which is the electrolyte used? Now here, questions can be framed in a number of ways for this particular process. It can be asked, what are the electrodes used? It can be asked, what is the electrolyte used? And so we will see which of the choices, 1 and 2, 1 and 3, 2 and 3, or 3 and 4. Okay? And the answer is C. 2 and that is 2 and 3, both of them. 2 and 3 means copper hydroxide and acidified copper hydroxide. These are used in the electrolytic refining of copper. So, we have reached the end of part 2, which deals with metallurgy, and we have got a number of questions which can be framed from this part. So if you want to get more videos on all the subjects, then you have to like, share, and subscribe to 1 mark solution. Right? So it is a covering of the very big chapter of metals and non-metals in those highlighted points where we get where we will get the important questions that can be framed from this. So I hope that you have enjoyed and you have understood, and there is a feedback form which will be given to you, which you have to fill at the end of this. So
थैंक यू सो मच मैम, थैंक यू सो मच नुपुर मैम। आपने इतना अच्छा प्रेजेंटेशन और एक्सप्लेनेशन के साथ में समझाया बच्चों को। और आई थिंक जो भी बच्चे देख रहे हैं, कुछ की क्वेरीज थी कि मेटल ये चैप्टर सिलेबस से हट गया इस बार, बच्चों के कमेंट्स में देख रही थी शायद, आई डोंट नो।
actually it is not yet sure. CBSE is deciding on it.
ओके,
Yeah.
सो जो भी व्यूवर्स आप लोग देख रहे हैं, जो भी बच्चे इसको देख रहे हैं, तो आप लोग पढ़ लो चैप्टर। और मैम ने जैसे बताया है, प्रेजेंटेशन इतनी अच्छी क्लियर तरीके से दिया, एक्सप्लेनेशन, एक एक क्वेश्चन का एक्सप्लेनेशन, आपको 1 मार्क्स के एक्सप्लेनेशन मिल गए हैं। और मैं कमेंट बॉक्स में एक फीडबैक फॉर्म आपको दे रही हूँ, आप इसको फिल करिए। और आप फिल करेंगे, आपको 40% अगर इसमें क्वालिफाई हो जाएंगे तो आपके मेल आईडी इस पे करेक्ट डालिएगा। मेल आईडी करेक्ट नहीं डालेंगे तो मेल आपको करेक्ट मेल पे आपके सर्टिफिकेट नहीं इशू होगा। सो थैंक यू नुपुर मैम। और
Thank you
मोस्ट
for
वेलकम।
giving
आप
me this.
हम ऐसे ही वेबिनार में आते रहिए, प्रेजेंटेशन देते रहिए, और जो भी देख रहे हैं बच्चे उनको भी मैं बोलना चाहूँगी कि आप लगातार इस सीरीज से जुड़ते रहिए। हमारे साथ बहुत क्वालिफाइड एक्सपर्ट्स आते रहते हैं जो कि आपको 1 मार्क्स के जो भी आपके डाउट्स होंगे उनको क्लियर करते रहेंगे। थैंक यू सो मच मैम। थैंक यू
Thank you.
मैम।